as Koshi mentioned, I'm kind of got one foot in arts technology and the humanities and another in the engineering school. I'm basically a computer scientist by training. And so that's kind of how I'm leading into this. So I definitely am like the rest of you. I'm obsessed with functions and math and everything associated with that. I want to start out with kind of something I found online.
Yes.
Oh, it sounds like someone's got their mic on.
Right. So I didn't know that. I thought, you know, it would be.
Okay. Anyway, that has to happen at least once in a Zoom call. That's a required. So if you look at this particular paragraph, it says the length of a shadow is a function of its height and time of day. Okay, that's in English. As people who are math knowledgeable, we know we can sort of convert that into mathematical symbols. And this is basically taken from functions in the real world. I do have some animations in this slideshow, and I do have a lot of links. So if anybody wants the PowerPoint deck, I'd be more than happy to provide it afterward. So that's like the key English phrase there. Okay, that's kind of a way of approaching functions from a linguistic perspective. But I want to just give an overview of what I do in my modeling class, and I'm just going to do that by way of literature art, or the liberal arts, and fine art. So this is just a quote from Edgar Allan Poe in one of his stories called Shadow, a Parable. And the idea here was I just wanted to take something that would come out of literature, maybe something you'd read on the news, or you'd be reading fiction, and highlight the objects, the verbs, which kind of gets to function. And in this case, the target of the shadow, which is tapestry, because the shadow casts a clear outline against the quivering tapestry. It's an outline of a person. And so this is the kind of question I ask my students. I've got a bunch of grad students in computer science, and I'd say to them, go get something on Project Gutenberg like this, and pick this paragraph or this chapter and tell me where the functions are, right? Or I'd actually, because I'm a computer scientist, I would say, okay, give me, you know, a particular formalism that we use in computational thinking in computer science. Or I'd say, here's some art from the Surrealist era. It's got shadows. Tell me what the functions are. So my class is kind of obsessed and involved with that. So in a way, what I'd like to kind of focus on today is nourishing the conceptual, which is this question mark right here. This is the statement from the previous slide. This is what we're given in, you know, trying to find functions in the world. And then when we do find them, we might sort of try and formalize them a little bit like this, and eventually get the student to go into problem solving. At least this is my naive understanding of what a teacher of mathematics might do. But it's this question mark here. This is the part that really interests me, is what are the stepping stones needed by the student just to get them thinking about functions before they get to formalizing them. And I'm not going to go over this in great detail other than say this is a concept map. Many of you, I know concept maps are used widely in education. So I happened to find it by searching on the internet, and sure enough, this is the kind of thing, even if simpler, I'd like to see students create. If we were talking about shadows, for example, you know, what causes a shadow, and so forth. So this slide is a concept map, and that could be perhaps a way to get to the formal, to get to the problem solving, but even before you get to the English statement. So this is the part of the concept map that that deals with what's going on with a shadow. So here's just some ideas. This is a conversation I'd like to hold. I'd like to have conversations with students and teachers that are kind of like this. You're outside and you're struck by shadows made by the sun on objects. Your spade, a column of the house, the family car, your own body. You're kind of just feeling out the idea of shadows. And then knowing what a function is, at least in some sense, then how does the idea of a shadow translate into the mathematical language of function? And then we can go on to add, this just involves a function with one input. If you have more inputs, that's something that you can talk about with a student. Now, this is all done before using X's, Y's, F's, and G's. And some of this stuff I'm going to skip in the interest of time, but this is a kind of a one way of taking things in the real world and thinking about function. One way to begin is to start with number, which is in many ways is more fundamental to math than function, and how we might do that. So here's an example of real world functions, and we're using object properties. So the student has a breakfast scenario. They've got a breakfast table. It's got 4 fruits on it. The fruits are identified as objects 1, 2, 3, and 4. And then you could proceed to talk about functions. The color of fruit number 2 is red. The size is 1 inch, and so forth. So, presenting the student with what's on their breakfast table is a great segue into functions. Here's another example, and some of these may not seem like functions, but there's so much everywhere that we look, you can kind of imagine. So you pour milk into a cup. So what's the function? So maybe fill is the function, and pouring, if you think of it as a function machine, which is a common in math education, then you put the milk and the empty cup into the machine called fill, and then the output is a cup of milk. So what goes in are 2 inputs, and what comes out is the composite cup of milk. You go out and you get the mail. Get could be the function. In that case, you might be the input, and what comes out of that function is you plus the mail. It's really almost identical or very similar to the cup of milk. And so I'm going to skip that and just sort of say, hey, in my world of computers and programming and computational thinking, I kind of see what we do in programming as functions on steroids. There are many functional programming languages, and I'm just giving an example in one language called Python, which is the hello world example, print hello world. Well, print is a function, and hello world is an English phrase that goes in the function. And so this is kind of meant to be a graphic of what that function is. And there's a great explanation of this in video on Georgia Tech. So I've got some additional material, and this is stuff that I'm going to go over very quickly and then finish up. This is just some stuff on function machines, with the function machine on the left, maybe looking like this in 3D and in 2D. And in computer science especially, we'd have a diagram like this. And then for more complex functions, you have more complex diagrams. And then you even have composite functions where you've got functions of functions. And this is from Math Insight. One thing I kind of like to do with students, and just to think in general, is that you can take any algebraic expression and turn it into a function machines. So these are just 2 example expressions, very simple ones. Y equals f of x plus 4, y equals ax squared plus c. And what's it like when you translate that into functional language, especially when you translate it into a functional diagram using this idea function machine. So this is what it looks like, and this is what it looks like. And then as a kind of last slide, this is kind of a classic formal description, that we may go over with students of, well, this idea function is very abstract. And as mathematicians and computer scientists, we want to get the student to understand the idea, the very essence of what a function is. And so this can help as they kind of move along in providing this sort of diagram.